changes rocks inside of the earth. So I'm going to give you a rock, and we're going to use our science imagination. This is a rock. Does that look like a rock?
No.
We're going to use our science imagination. Put it to your science imagination. This is a rock, and we're going to send this rock. You take this rock. We're going to send it to the center of the earth. Send it right here to the center of the earth. Okay, the center of the earth is pretty hot, so put it in there and then push it down. Okay, push it down. There we go. Stick. There it goes. All right, stand on this side, because I want you to watch your rock while we check out some other earth forces, because we don't want our rock to burn. That would be bad. So heat is making the rock change in the center of the earth. I need another earth force to come up and help me out right now. Will you come help me on this one? Here we go. You are going to be pressure. Do you know what pressure is? What's pressure? Do you know what pressure is?
Yeah.
What's pressure?
Like if there's something, like anything,
Okay.
and then like wind comes and then it presses.
Presses and pushes, right. Pressure is pushing and squeezing. Can you guys all put your hands together like this? And squeeze. Good. We're going to put some pressure on another rock. I'm going to give you this rock. Can you squeeze it up into a little ball? Put some pressure on it. Squish it, squish it, squish it. Yeah, there you go. Good. She's taking that rock and she's putting lots of pressure on it. And let's check it. Does it look different now than when you started? Did she change that rock? Yeah. She did. That rock got changed. Excellent. It's really squished. Go ahead and hold on to that squished rock. Pressure can change rocks. Heat is changing rocks. And of course, I need one last force. I need some gravity to help me. Will you help me on this one? You're going to be gravity. Here we go. What is gravity? Do you know what gravity is?
Something that was something. Oh, it keeps it on.
Keeps it down, right? Gravity is what pulls something that goes up. Here, stand right here next to pressure. Something goes up has got to come right back down to the ground. Just like that, right? Gravity is what makes the confetti fall back down to the ground. And gravity pulls rocks towards the center of the earth as well. So, gravity, if I give you this big book and you let go of it, which way is it going to go? Down. Okay, don't let go yet. Because remember, we're working on our rock. So let's check on your rock heat. See if it's changed.
Whoa.
Is your rock different? Yeah, what happened to your rock?
It got burned.
It got toasted, right? Feel it. Does it feel different?
Yes.
Well, it's hot, but does it feel scratchier?
Yes.
Yeah, harder. Okay. So we're going to take this hot rock right here. Stand back for me a little bit. I'm going to put some space so everyone can see. And we're going to take our pressure rock and we're going to put it right underneath, okay? And now gravity is going to make a change. Lift it up real high and then drop it right on there. Do you think gravity changed our rocks? Let's find out.
We got smushed.
Yeah, did we squish them?
Yes.
So gravity can squish rocks together and change them over time too. Let's give a big round of applause for each and gravity. Thank you.
That was fun.
Thank you. So these earth forces are working on rocks all the time to change them. But let's check our rock here. Do rocks actually get toasted like this?
No.
Do they get crispy and crunchy when they go into the center of the earth?
No.
What happens to a rock if it gets pushed down into this part of the earth? What happens to it?
It becomes hard and
Hard and hot? Well, definitely becomes hot. But as it gets into this ooey gooey center, something else starts to happen. So a rock is not quite like toast when we send it to the center of the earth. Instead, it's more like chocolate chips. So we're going to take these chocolate chips and we're going to send them to the center of the earth on this little hot plate right here, okay? This is going to get pretty warm. It's going to take a minute. So what I'm going to do is I'm going to put our rocks on the hot plate. They're all chocolate chip shaped right now, right?
yes.
Okay, we're going to put them here. We're sending them down into the middle of the earth where it's really hot, and we're going to check back on them a little bit later. So inside the earth, rocks get changed as they get warmed up, and we're going to see how they might change as they warm up. But on top of the earth, rocks get changed all the time as well. What's the biggest rock you can think of? What's the biggest rock you can think of? What can you think of? Yeah. Earth, the whole earth is a big rock. And the earth is actually broken up into pieces called plates. Have you heard of plates before?
No.
Yeah, so there's these big plates of rock that float on top of the mantle, move around very, very slowly. So on those plates, if you had one big, huge chunk of rock, that you could touch and climb on, what would you call it? What do you think? Big rock. What would you call it? A boulder. A boulder would be a big, huge rock. You could climb up on top of it. What if you had a bunch of boulders in a stack and then there was dirt and grass growing on? What would you call that?
I don't have to say a comment about that.
Okay.
I have a comment about how we use big rocks in one way.
Okay, can you tell me in a little bit? Because right now I really want to know, what's a big, huge rock sticking out of the earth called? Have you heard of it? A mountain. That's right. A mountain is a big, huge rock. But rocks come in all different sizes. There are mountains and boulders and stones and pebbles. And even when rocks get really tiny, we call them sand. So we can read a rock like this and see how it's been changed on the surface of the earth. This rock, I know, came from inside of a volcano. And I know that because it has lots of little speckles. So I know that it got heated up and different minerals mixed together and then cooled down. But I didn't find this rock near a volcano. I found this rock far, far away from any volcanoes by the beach. How do I know? How can I guess by reading this rock how it got to the beach?
Maybe throw off the volcano into the water.
Oh, and maybe it fell into the water. What makes you think it might have fallen into the water? What do we observe about this sample of rock? What do you notice about it? Yeah.
That it was in the volcano and then shoot it into the sand and then it came out in the sun.
Maybe it shot all the way, but the volcano, the closest volcano, was really far away from the beach. It would have been too far for it to fly through the air and land at the beach, so it had to get there a different way. So what do we notice about it? Yeah.
The water just pushed it towards the beach.
The water might have pushed it towards the beach. What do you notice about the texture of this rock? What does it look like it feels like? What do you think? Smooth. Maybe the water smoothed it out. Excellent. Because I have some other rocks that came from volcanoes, like this one. Is this rock smooth?
Yes.
No, it has all these sharp, pointy spots on it, right? Or what about this one? Is this one smooth? No, it's all rough and bumpy. So I know this rock came from a volcano, but it got smoothed out as it went down to the beach. And it probably did that as it was moving through water. How does this work? Well, water makes rocks tumble and crash against each other, like this. This is kind of a loud sound. I have a bunch of rocks in here. Let's see what happens if they tumble against each other. Did you hear that?
Yes.
Do you think some rocks, as they tumble down a river, might get broken up into little pieces? All their sharp edges might get broken off. So I need a couple volunteers. Let's have 3 volunteers help me with this one. Can I get 1 and 2 and 3? Come on up and help me over here. Come on up, come on up. Here we go. Here's what we're going to do. This is a piece of granite. Have you seen granite before? Yeah, usually we can find it inside of the mountain. Take a look at that one. Take a look at that. This is a piece of granite, and I put some granite inside of this bottle. Do you guys see the granite in there? Okay, we are going to make the granite crash and tumble against each other inside of there. Just like the way they do when they run down the river, the rocks tumble and crash against each other. So here we go. I'm going to shake it 10 times, and then we're going to pass it down. You ready? You guys going to help me count? It goes like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You shake it 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Pass it down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Pass it down. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good. And I'm going to do it one more time. Ready? Really hard. Count it out for me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. Now we're going to check what's inside. Did you see that?
Well, I saw some smoke.
No, it's not smoke because it's not hot in there. Do you see the dust coming off?
Yes.
So as the granite has been crashing into each other in there, it's made dust. Can you feel the dust? Right in there. Do you guys see this dust?
Yeah.
So they smashed all the granite up, and they made this dust from smashing the rock into teeny tiny pieces. Round of applause for all my rock smackers. Good job.
I hate dust.
There you go. That's okay. Good job.
I
So rock can get tumbled and broken by things like the river tumbling against each other, water and waves. In the ocean, have you seen these smooth rocks like this? all the sharp corners get busted off as the rock is banged against other rocks as it gets tumbled around by the waves and the water. So it's nice and smooth. Eventually, this rock will break down completely and turn into sand or dust, right? Very cool. There's other things that can make rocks break, though. I need 5 volunteers to help me with another experiment, and hands down if you helped already so we can get some new helpers. Can I get 1? Come on up. And 2. And 3. I need a couple more. Yeah, come on up. Anyone help too? Anyone who hasn't helped yet that wants to help? You didn't help yet. Come on up. So I'm going to have you guys stand next to each other, okay? Just like this. Stand next to each other just like this, and we're going to imagine that you're a mountain. Yes, you're a mountain. Do they look like a mountain? No. They're big and strong like a mountain. So we're going to imagine they're a mountain. Good job. Here's what's going to happen. The rain is going to fall down on the mountain. And as the rain falls down on their heads like this, it rains on top of the mountain, right? It gets in between the little cracks, right in between. And then when the water freezes, it actually expands. So at some point, the water is going to go and crack off a chunk of the mountain. And he's going to fall down this way. And now we have a mountain and a boulder. The boulder is a little bit separate, right? And then maybe over thousands of years, it rains a little pour on top of all of the mountain, right? It rains on the boulder too. And then the water gets in a little crack, and it expands, and it breaks off another boulder. And now we have 2 boulders and a mountain. And over time, the mountain gets smaller and smaller as it gets worn down by water freezing and melting, or by wind blowing across and shaping the rock. This is all called erosion. Can you say erosion? Erosion. A round of applause for my mountain. You guys can have a seat. So let's check back on our melted rock here and see how it's doing. This rock has gone inside the earth. Right now it still looks kind of chocolate chippy, but it's actually very soft and squishy. Look at what happened to my rock. Whoa. It got all melted and gooey, right? All melted and squished and gooey. Because it's been melted inside the earth.
Well, I want to eat it.
Yeah, it's not for eating, unfortunately. So rock that's been melted inside the earth is called igneous. Can you say igneous?
Igneous.
Igneous rock we find in volcanoes and such. And it comes in a couple different types. Some of it has fluffy little air bubbles from tumbling through the air like this. See those little air bubbles? And it's very light. It almost feels fake. You see that? This fluffy little air bubbles. Another kind of igneous rock that does not have fluffy little air bubbles looks like this. We saw this one before. This is called obsidian. For all you Minecraft players, it doesn't come in cubes. It comes in chunks like this, right? And it looks like black glass. So this is another kind of igneous rock. Metamorphic rock is rock that's been shaped by pressure and squeeze. Do you see how this big chunk of rock right here has lots of different parts squeezed together? This is metamorphic rock. Deep inside the earth, the forces and pressures have squeezed it and shaped it. But there's one more type of rock that I want to explore. It's called sedimentary rock. And sedimentary rock is formed on the surface of the earth by layers layering up over time and then squishing together. So let's see how a sedimentary rock might form and also leave some special fossil clues behind for us. So Miss Katie, come on over here. She's going to put down some dirt for us. So this is our first layer of dirt. And we're going back in time millions and millions of years ago when there were dinosaurs. Sedimentary rock is the kind of rock that we find fossils in. So I need a dinosaur to build a nest on this rock. Is there anyone who hasn't helped yet that wants to help? Everyone who already helped? Okay. So let's have you come help me out again. Come on. We'll go there. So first thing we're going to do is we're going to need to tear this up and put it in the paper nest. Can you do one? Okay, you take that one. And then I'm going to do one. The dinosaurs would use rotten vegetation to pad up their nest. Just a minute, okay? And they would put it all down like this because that would keep the baby dinosaurs warm. So put a couple pieces in there just like that. Put them right in there. Good. Can you put that last one in there? There we go. That's good, that's good. Let's put this piece in right here, okay? Round of applause for my dinosaur dad. Can you have a seat? So now I need some dinosaur babies to be in this nest. Who didn't help yet? Did you want to help on this one?
Yeah.
Do you want to help out? I need a dinosaur baby to be in the nest. Do you want to be in the nest? Come on over here. And dinosaur babies, of course, need eggshells. So I'm going to give you an eggshell. Okay? So here's your eggshell. There you go. Alright, can you curl up right inside your eggshell on top of the nest? Good. And I need another eggshell. Anyone else want to be an eggshell? Maybe an egg on this one? Stand right in the nest. There you go. Here's your eggshell. Okay. And then get down little. You're curled up inside your egg. Now, our dinosaurs are about ready to hatch. They're going to hatch out of their eggshell. Can you tear it off? Tear off your eggshell. Tear it off. Tear it off. Tear it off. Tear it off. There you go. Good. And it falls right down in the nest right there. Now, our dinosaur babies are hungry. Can you catch some food? Catch some food. You can stand up. Stand up, get some food. Get some food. There we go. There we go. As they try to get some food, they end up stopping on eggshells. Stop like that. Stop, stop, stop. There we go. Right there. There we go. Stomp, stomp, stomp. Excellent work. Round of applause for my dinosaur babies. We make sure we are something out in the world. Okay, have a seat for me. Thank you, thank you. Now, after some time, we see our nest has been abandoned because the babies grew up. Good. Thank you. Thank you, thank you. So, some water washes over our nest. Some muddy water washes over and covers over our nest. And then it disappears. We don't see it on the surface of the earth anymore. Over time, more and more and more layers start to stack up. And just like my catalog here, it's heavy. Is one page very heavy? No. One page is not very heavy, but when I stack them all up, they get very heavy, and gravity pushes down and squeezes them together in a process called concretion. All the sandy parts and the eggshells get fossilized, and the vegetation is squeezed together and turned into rock. Now, in a couple million years, maybe we would see this on the side of a mountain, and we would see the layers of sedimentary rock. Do you see how the layers are trapped in there? Yeah. We have our layer of dirt, right? Our light-colored layer of dirt, and then we have the nest with the eggshells on top of it, and some muddy water washed over it, and it all got squished and stuck together to form sedimentary rock. Pretty cool process. So, of course, everyone loves some igneous rock and some volcanoes. We saw our samples of igneous rock right here with lots and lots of bubbles in them. Has anyone here ever made macaroni and cheese before? Macaroni and cheese, you've got to make the water hot. And what happens to the water when it gets really hot?
Bubbles.
It bubbles. It boils. You've had it before? When water gets hot and bubbly. Rock inside here can get hot and bubbly too. And if it gets flung out of a volcano really, really fast, gets lots of air bubbles in it and makes this kind of rock called pumice. So I need a volunteer to help me with my volcano today. Will you help me with my volcano? We'll put our picture over here. So here's our volcano. And we're going to need to add some stuff. Will you stand right in here? So we have some baking soda in our volcano already, and we're going to add some of this to make our volcano erupt. And then I want you to watch closely and see what we notice. So go ahead and take a little bit of this. We're going to pour it into the funnel, okay? There we go. All right, what do you see coming out the top? Our volcano's erupting, but what do you see? Because you're close. What do you notice about all this red stuff coming to the top? What's in it? You see these little things? Bubbles. There's bubbles in it, right? There we go. Let's see if there's any baking soda left. We'll add a little more. Oh, there's a big one. Do you see the big one? You guys see the big one?
Yeah.
There's our big bubble. chance to see what it's like in the center of the earth. Would anybody like to go on a magic school bus ride with me? If you would like to go on a magic school bus ride with me to see what it's like way down there where a rock is getting formed, go ahead and line up behind me on this line right here. We're going to line up right here on this line. Come and join me to the bus. Thank you so much. There's lots around. Have fun. All right. Seatbelts, everyone. Seatbelts on. Buckle up, buckle up. Good. All right. We're going to head out from the museum and go down, down deep. Let's get this bus started. Say, come on, bus. Come on, bus. Our bus goes out away from the museum. We're going to need to go down deep. What do we need to dig through all this dirt? We're going to need a jackhammer. So our bus turns into a jackhammer. I want you to feel the shake of the jackhammer as we go through the dirt. Shake your knees, shake your knees. And as we're going deeper, we hit some hard rock way deep down under the dirt. So we're going to have to put on this heavy, oh, it's the big one. Okay, take out the big heavy duty jackhammer. We're going down deep, it's getting hot. Getting hot, all right. Okay, we're going to have to put on our special protective suit. Come on, one leg. The other one. Put it over your arms, zip it up. You're going to need a helmet too. Put your helmet on. Good, all right. Oh, it is hot. There's melted magma down here. Oh, oily and lovely. It's hard to put your body through it. All this hot magma. There's the bubbles coming at you. All the bubbling hot rock. Kind of this Nice. You feel the washer of the particles? That's all. Come over here. I want you to feel my force over the top of your head, and it's going to squeeze you smaller. The pressure's smaller. Squeeze you smaller. The pressure's squeezing you. Oh, you're going to squeeze even more. Uh-oh. The earth is starting to shake and rumble. Oh gosh. Guys, I think we might be close to a volcano by here. It's starting to rumble a little bit. Let's head back to the bus. As strong as you can. Let's go back. Go back to the bus. Yeah. I think we're near a volcano. We're going to have to go back. Come on, let's go. All the way back. Push through. Yay! Hot magma. Oh, yes. Come on. All right. To the bus! Look up there, guys. I think I see some daylight. Seatbelts, everyone. Take your seatbelt on. I think that we're going to get tossed out the top of this volcano. Hold on to your hats. Whoa, there it goes. We're getting exploded out the top of the volcano. Uh-oh. Uh-oh, we better get the bus started before we fall down into the ocean. Come on, please. Say, come on, bus. Come on, bus. There we go! We're gonna spread our wings like this. We'll soar back to coming in for landing. Whew, we made it. Go ahead and take your helmet off. And you can take your special suit. Just leave it there. Me and Miss Katie will get it later. And go ahead and have us. Good.
You know what? Kind of cool dresses. Yeah. Our pens are.
Well, class, that is all the time that we have for today, but I would like to invite you to join the museum here. Next Saturday is Family Day. The theme is going to be Nature Detectives. From 11 to 3 p.m. there will be all kinds of crafts and activities. I've heard that Project Wildlife, who rescues wild animals, is going to bring their hummingbird ambassador to visit. So if you want to meet the hummingbird, that would be a good time to visit us. I will continue to be talking about geology for the rest of this month. And next month, we are going to be learning all about chocolate and the rainforest. So if you'd like to join me in January, we'll do that. The museum is holding winter camp over winter break for the first time ever. in the museum store if you'd like to look at those. There are some samples, and then if you'd like to purchase any, those are available at the museum store. So thank you so much for coming today. Do you have a question?
When I went to the bathroom,
Oh, all right. Well, if you'd like to see any of my rock samples, you're welcome to. Please keep an eye on little ones. Our hot stuff is unplugged, but just want to make sure they're not sticking fingers in the toaster. They come on up, and they're welcome to look at any of my rock samples, and I'll be over here by the volcano if you need pictures or you want to say hi, okay? Thank you, guys.